Alright, in order to keep it from getting too long, I'm going to make this film as I go along, and it's just a review of what I found over there in terms of structural issues and in terms of anything else that I will mention along the way. So starting in the basement, this is this area under those front porches. The first floor is shown in red here, the overlay, and these areas here, including this one for some reason, but these areas in here, this is all lowered. Every bit of this is lowered and by 6 inches, and then presumably they have poured concrete in, at least in these areas where the exterior vestibules are. They've poured concrete in that, and presumably here and here as well. In any event, this rotted wood, as you know, this will have to be replaced, but any of those members that are not rotted, we find. And you might, this one here, I don't know if you're going to be able to get that back up on the foundation wall, so you might have to put some treated lumber columns in. But any of that lumber that's not treated has to go. It's been put in there as shoring because of leakage from outside, so that leakage from outside needs stopped as well. But in any event, any of those members will be replaced with treated lumber. But in terms of the floor framing through the rest of this first floor here, it's 2x12s at 16 inches on center, and they're rough 2x12s, so they're almost 1 3/4 inches by 11.5 high. This area here where they cut out that floor section and put these in here, this is fine. I would change out these 4x4s for treated 4x4s with some sort of a base and cap to attach them to this piece at the top, this 4x6 at the top. And I would just put 2 back here as well. There's only 2 joists that have been cut coming through there, but that's adequate to hold them as far as that goes. And the second area to look at is this area here where they've cut out for that furnace that's still down there. And here they've only cut 1 joist, and they have it headed off, and I see no evidence of that failing in any way. The city and other jurisdictions, though, generally want these 2 side pieces to be doubled through here, and they want hangers used where these hang on here. But right now this seems fine to me, and it's holding up. And then the other area of this floor, I don't know why, I can't figure out offhand why they've framed this section of the floor like they have. They've put these 2x12 beams in here and then other ones going across. I don't know why that's there, but in any event, pretty much that whole section of floor is going to have to be replaced with new lumber through here, new 2x12s. And then the last detail to mention is here where they have this door buck built with 2x4s kind of going across this way. Returning to this, I might understand why they did it this way, and it could be they want to reduce the load on this opening through here, because this opening just has a couple 2x4s on both sides, one on this side and one on this side, but there's at least a joist or 2 dying into here, like they've headered this off again at some point. I don't have a photograph that shows it, but it's, you know, something like this, and then there are additional, some of these 2x10s, at least if my memory's correct, come over like this and are bearing on this bit here. And so when this is all rebuilt, if I end up drawing the plans for how to rebuild this, I think I would just put headers across this way, flush beam headers across this way above that opening, and then just run all the joists this way and have them sit on the wall here and here and here, and then across this area hang on these vertical 2x12s across here. I will have to double check and see, but I'm pretty sure that's what's happening in that little region right there, and that could be why they have framed that way back in the day. One thing I'll mention with regard to replacing these various members, these floor joists anyway, is at least you don't have to worry about a floor plate and that sort of thing, because these are just pocketed into the wall. What you'll have to mention or think about though is that that brick wall is built on top of those, and one way or another we have to, and I don't know if these pockets go all the way through, but one way or another we have to figure out how to drop these in to place, which means of course all that flooring will be gone too. But I don't know if we're going to be able to slip new ones in there until we get that open and see what you've got to deal with in terms of getting those new floor joists dropped in and fitted into these existing pockets in the concrete wall. The good news about the actual floor framing though, the general floor framing, and you can tell when you walk around up there it's pretty stout, is those 2x12s, they really, when I put this in, when I put in the member information, the spans, how far everything's spanning, and then we put in the loads, you are only required to put in 40 pounds per square foot here on Floor Live, because that's an existing building. I'm not sure what they would want anyway, but you're allowed to put in 40 even because it's an existing building. If it were a new commercial building, I don't know what that rating is. I'm going to interject because at the time that I was saying that, I went and tried to track down exactly what is going to be required, what they're going to want for your floor loading. It's generally based on the type of function it is, and according to this calculator, they're saying that mercantile is 60 gross square foot per person, which means for every 60 square feet, they're going to allow you to have one person in there. And when you do the math on yours, 2380 interior, well, they actually use the exterior, which is 2660, divided by 60. You end up with your maximum capacity they're going to want you to post is, I think, could be wrong or right, but I'm pretty sure they're going to want you to post the maximum capacity is going to be 40 persons inside the entire 3-unit, the 3 buildings together, the 3 spaces together. So I'm pretty sure that the estimated number of occupants for the area is going to be 40 total, which it comes into play in the parking calculations and in this floor loading calculations. And after much tracking down, it looks to me like OBC 60, they're going to want 40 pounds per square foot. So we're going to run with that for now and continue the film where I was. Generally you have to put in 40 for residential floor loading on that first floor. And when we put in 60 even, we're still passing, and we still have some room to move on that even, and I don't think I experimented much further than that. And this Floor Live is the people and the equipment and whatnot and the inventory, whatever else you might have up there. And we'll see if this will pass at 70. Even at 70 pounds per square foot, most of these species pass. And I'm presuming, because of the time this was built, that is probably Southern Pine #1 down there. But I'm no wood expert. But I'm sure that that is pretty stout wood, and it's passing at 70 pounds per square foot. So, in my estimation, that whole floor system is good, except for this area that's rotted because of issues with the roof. There's probably some rot here. I don't know what that ripple is on the first floor. I think it has to do with the subfloor. Maybe there was some sort of water issue at some point, but I didn't see it from downstairs what the issue was. And then the other thing is, this bit here, like as I said, this has been dropped, but the first floor extends all the way into here. And so once we come across this beam, I think all that subfloor has to come out and see what's been done under there, because that's pretty spongy through here. So you can see the floor system is very stout, passing at 70 pounds live load and 10 pounds dead load. At the first floor, besides the floor and roof, on the first floor, these walls here that are running north and south, these seem in good shape to me. These ones here this one's pretty shady where it's holding up that beam, and this one looks pretty good too. This one here, this needs rebuilt in some fashion or another. That needs put back together. This is not really a bearing wall per se, but that, as you know, the condition of it. So that needs put together, and that's obvious. It doesn't need to be told. But in terms of these, the roof joists, that was the next member I tested in this beam sizing program. And on those, once I put in these spans and supports, the loading required there is just this snow load, the dead load of 12, and I think that can actually be 10, but then the snow load of 20, and we know they're 7¼ deep and they're spaced at 24 inches, and we just select all these different wood species. And the best of those, and considering this was when it was constructed, I'm assuming that those are also Southern Pine #1, those roof joists, which pass. Now if we get down to some of these other species, which #2 Doug Fir or #2 SPF, and they're not, they're definitely Southern Pine. I don't know, I doubt that. I think they're Southern Pine #1, and you can tell because most of that roof, most of those roofs, this seems pretty stout in through here in any event. And then we start getting issues on this side here. But when you look at them from up on a ladder, some of them anyway, you can definitely see that they're bowing for whatever reason, even though they are passing, and presumably those will pass on the code charts as well. And it's nice, they've got the bridging up here and everything, but when I look at this, it looks to me like there is some deflection in through here. Those ones back there look straighter, but in through here, and note that this is right where we have this change in beam height at that masonry column. But I think it would be nice to stretch a string and see what those are deflecting, as well as seeing what that beam is deflecting. A few more looks at the deflection. This is the beam sloping down here, and they're all deflecting some, and they are, they are going to deflect. These ones that pass, there's, under the total load deflection, they're expected, but there's nothing up there right now. They shouldn't be deflecting. But in any event, over time, perhaps over 100 years or whatever it's been, their total deflection should have been maybe 5/8 of an inch. And that one's obviously, maybe that was a faulty piece. But you can see the bow in this one here as it comes down to this section of the beam that's level. And for this roof to be put together the way it is, there has to be some twisting of these planks on top. That's the only way that that would be able to follow these roof planes like this. And maybe that's just the way they did it, as we talked about on the phone. But I mean, the bow, it wasn't super severe. I don't know if it was more than an inch, but that's, you can see that it's there. Anyway, that's that on that. We'll take a look at those and see what exactly is happening, because as I said, they are passing with most of the species except these two down here. When we get down to there, they start to fail. Here is the bearing at this end, and really at this point it is relying on these two vertical 2x6s, rough 2x6s, because this is all kind of gone. This should be put back together from wherever it is down here where it starts to deteriorate all the way up with just the same thing, I would think. Otherwise, they frown now on using wood to support steel. So otherwise, I would replace this with a piece of a steel column. But assuming that those are Southern Pine #1 or one of these other two species, they pass with the required loading, and they wouldn't complain anyway because it's an existing building. But they do pass with this required snow loading. The next thing I reviewed were these members here. Those are left up there. I would think that those would be just left up there, and that would be ceiling there. But in terms of whether or not those are able to support those window wells, and additionally I would just remove those, not window wells, I would remove those chutes to the roof unless you have some use in mind for those. but I did run these through just to see if they were going to be holding the load of that plaster and framing up to the roof. And I don't know what species that wood is up there, those double 2x6s, and this just tests standard 1.5 wide. Those are full 2 inches by 6 inches, so probably all of these species would pass and it wouldn't be so miserable. This was failing just at 107%, so probably they would all pass. Particularly they will pass if I remove these loads, this well partition load from it, because then all we'll be carrying is presumably drywall and perhaps insulation in that space. So if I take off those partitions, and from both of those, if I take off the load of that partition from both of those, and now it's just, and add the dead loads on those, and then we pass again, except for these two species, we're passing for that to carry drywall only and insulation, drywall and insulation only, with no attic storage. And actually that area down there, it's never going to have attic storage because it's so low. So the short story is, I think once those partitions are removed, that area, once those wells to the roof or whatever are removed, that framing I think could just be left in there to carry your drywall. The next members that I reviewed is the steel members, beam 1B and beam 1A. And this one's sloped and this one's level. When I was last out there, I measured that again, that beam again, to make sure what I was measuring, and I measured it at no more than an 8 1/8 high and 5 1/4 wide. But I measured the web thickness as about 0.31 for the thickness of that beam, the size of that beam. And this is these American, now I don't know when that beam was put in, whether it was put in when the building was built or at some later point, but these are these wide flange beams and their sizes, and it's based on the height, W8 being roughly 8 inches high. And so these ones here at 8 1/4 and 8 1/8 or so, maybe it's this 8 1/8 by 5 1/4, but that is showing when I look at W8 by 18, 8 1/8 by 5 1/4 wide, they show the thickness at less than 1/4 inch. And I'm pretty positive, I mean I didn't have a micrometer, but I'm pretty positive that I measured something closer to this 0.310. So, and I'm not familiar enough with these wide flange beams to know if there were different manufacturers that made them in a different little variations in the sizes, but that thickness is going to be significant in how much of a cross section, how much it's going to be able to hold. So I'm thinking that it's probably closer to something like this 8 by 21, W8 by 21. So just for fun, this column here is this cross-sectional area, how much area a beam takes up, which is going to relate to how much it can hold. So just for fun, to see something, I went and modeled this beam exactly on that. I measured it exactly 8 inches high, exactly 5 1/4 wide, and I hypothesized that I was correct on that 0.31 web thickness, which is this bit here and this bit here. When I do that, that cross-sectional area is that, and when I convert that, it comes to 5.4 square inches, which is right here. And you could see on that lower one, W8 by 18, which was one of the possibilities, it's 5.3, and when we get up here, it's 6.2. So for now, I'm going to, just for this process, I'm going to act as if it were that heavier one. I really don't think it is. I think it's closer to a W8 by 18. But this beam sizing program allows me to size these steel beams as well with these simple loads on it. So I wanted to look at beam B, beam 1B, and beam 1A. And I'm going to assume that they are this in terms of analyzing them to see what the program is saying, whether they are passing or not. First, when I started doing this, which was just today, I updated these plans a little bit more, and I had named these just so that if we're speaking, we'll know what we're talking about, or anyone's speaking, they'll know what they're talking about in terms of various areas, with this naming up here and then named by addresses down here. But I also added these dimensions here on the bearing lengths of these beams. And I think as I started running into some things, I lowered this bearing to just that wood, just the wood holding it up, because I was getting, this was failing when I was designing it, this was failing for an uplift at that end, and so I wanted to see if that would make any difference. I lowered this to 18'9" out to out, and this end only being the 4 inches, and we will act as if it's southern pine. I'm not sure what those two vertical members that are holding this up. At this end there's those two wood members that come up through here, and if we act like those are holding it up, maybe we won't get that same headache. And so that passes. So that was where we were getting the failure. Earlier it was that excessive uplift. Again, they don't like this steel bearing on wood. I don't even think they'll allow it in the code. But your building is existing, and they are acting like those two pieces, those vertical pieces, ignore that wall behind it, they are acting like those vertical pieces are enough to hold the 5,000 or 6,000 pounds that's coming down on that end. And I have these loads linked from this roof joist at number 3 and continuing all along that beam. So more good news really there, because this was earlier failing, and it was apparently just because I was showing this at that 16-inch bearing going over. It was really just those two pieces of lumber coming down, and those pieces of lumber are coming down on top of that foundation wall at the end of the day. So presumably that is okay, even if it were the lighter of those beams. Well, this is an 8x21, so if we switch that up to the lighter of those, then we get a failure at this 120% if it's the lighter of those two, and we've been through why I think it is the lighter of those two. Now, obviously, if we try to correct this with an additional column that I opined might be missing there where those holes are, and I don't know that that's right or wrong. That beam could have just been a used beam that they got, and those holes could have been there. I didn't look at where it was down at the foundation, but I don't recall seeing any kind of evidence of a plate or anything that a column was once there. So I'm not sure about my feeling on that either. But if we try to correct this beam by putting a column in, and we will just assume we're putting it in there where that is. We adjust this to reflect that, and then everything else stays the same. So now we have those spans, the same loading across the whole thing, and W8x18, the lighter of those beams that was possible, and that passes, and it passes pretty handily with that additional column in there. But without that additional column, not so much. Now, if a person was inclined, I guess, to replace that with wood, to replace that slanted steel portion with wood, and you went up to either of these, then it can be done. That span can be done without putting in the column. If you were inclined to go to the headache of shoring up the roof as it is and taking out that column and putting in wood, you can do that with as little as 2 pieces 14-inch microlam LVLs, or even a 13.5-inch glue lam will also do that clear span without that additional column, the whole 18'9". So that is really just for information for you to know. But as it is, you leave the steel in and you correct it in this fashion, it passes handily. And that means that we don't have to bother going any further with, we know that beam 1B is going to pass because that span is no more than this one here, carrying the same loads. So that is it on the review with regard to the structural things that I saw. You'll have floor repair here as well and a few other places, but mainly this section here. Now this next section is about the roof, and maybe the roofer will want to see at least this part of this film, this minute or two of this film. So all those dimensions that I took out there over 3 or 4 days on various points to the bottom of those rafters, I translated those the best I could into these drawings. This is a cut through the building looking toward 3rd Street. And this, it looks to me like generally the whole roof slopes, as we know, from north to south. But on the left side, it looks like these ones slope down this way. In the middle, they continue sloping down to that beam, that steel beam, and or the wall at that end. And on this end here, they also slope down, and they slope down a little less than these ones do. But that is what I found from the dimensions I took and translating that into this sort of a thing here. And so I made this diagram of the roof of just trying to understand how it is working, how it's put together, and how it's working. So this is sloping down this way about 3 degrees, and this slopes down this way about 3 degrees. Originally I thought the whole roof just sloped to the back, but there's a parapet wall here which didn't make that make sense. It didn't make sense for all that water to be coming down against this wall here, assuming that was all original construction. So, but with this sloping this way 3 degrees or so, these are also sloping down to this rafter. So what it means, at least at this section of the roof here, you take this corner here and push it down further than this one is here, so it almost seems like there's a twisting effect happening. And a similar thing happens with this one here as well. And then there's a transition where that sloped beam and the level beam, there's some sort of transition up there. But when you look at the photos of the roof, it looks pretty smooth as it is. And this is what I had originally been started with, was this sort of thing where it just sloped from the front to the back, but then all that water was coming against that wall, so that wasn't really making sense anyway, which is why I came in and tried to figure it out further. And that's actually how it looks. You can't see it from here, but this, putting that model together, it looks something like this, where this is the this is 3rd Street up here, and this is the northeast corner of that roof up here, and it slopes down here, and this is that little level section of beam here. This is on the west side, and it, you know, twists down this way. This was where I modeled it in my modeling program, and so it was able to be put together from that standpoint. And that is how I built that. You can't see the slopes on it. That's how I built that. But I was still curious about, is that thing, you know, is there a point up there where there's a low point and water's collecting? And so I do this where this is a flat slab, imaginary flat slab of water, completely level on the top. And we slowly lower that water table, and you can see that there is no water pooling anywhere, and it's making really good sense that that's the lowest point of the roof right there, and it flows off into that gutter there. But you had said that there might be a roof drain back here somewhere as well, so I'm not sure, but that was the best I could do, that whole roof situation to this point in the game. That's where I am with that roof. But I will say, to me, what it appears, if this is what's happening and this is what it's taking, that this is all built as they go, building up those walls of the brick and then laying these rafters in there, and those rafters are slowly twisting down here, and then that planking that's laid over top of them with those 24-inch spans apparently is just bent and twisted to follow these roof planes like that. And I could be completely wrong on that, but I wanted to come up with something to explain what was happening, and that was the best I could do. This is the last section of the film, and it's just concerned with your zoning and possibly your parking, if I have it right. Your zoning is definitely this EGC, and you are on this south side or abutting this mature residential 5. ECG means eclectic, general commercial, something like this. And your building is right here. So you have this, you're abutting this residential district. Eclectic general commercial district. And that's what they're looking for. And I made a quick review of what is allowed in this EGC district, as well as what the parking requirements would be given a given use, given a certain use. And you can come back and look at this film in slow motion and look at these charts or these tables if you want. But where there's a P, that is going to be permitted without any problem. And if it's an asterisk P, it's going to be further regulated by additional regulations. And the same with C, sometimes you can, sometimes you can't. And A is generally permitted as an accessory use. If the cell is blank, the use isn't permitted. And so multifamily dwelling is permitted, and the further regulation of that was that you needed at least 5,000 feet on your lot. And your lot is slightly over 5,000 feet, it's about 5,200 feet. And so these are the things that are permitted and not allowed, etc. Some of these retail establishments permitted by right. And I don't know how many other of those would apply to what you have planned to use that for. Next, these are the basic development standards, and you do have to comply with some other architectural standards as well if you do anything outside. But yeah, with the multifamily dwelling, their extra regulation was that you needed at least a 5,000 square foot lot to do that. And none of the other this is important or applies to you right now. Now, when we get down here and start talking about parking, though, we are in this ECG, and this is kind of significant. And if it abuts a non-residential district, the setback from the line to where your parking lot begins, to where you're allowed to begin parking cars, is 10 feet. But if it abuts a residential district, it's 15 feet. And I don't know whether Mercer Avenue qualifies in cutting you off from that residential district so that you would be able to do it at 10 feet back. But it's really pretty significant, that extra 5 feet, because it's going to be the difference between whether we can get 7 parking places in there or whether you can get 5. And I could not find a way to get more than 7, by the way. And we'll cover that here in a minute. And by the way, you could build your building, if you were rebuilding it, you'd go up to 40 feet high. And it's currently about 18 feet high. And this is what I mean, there's a lot of different things if you're going to change around that front at all that you'll have to be considering. But when I came down to look at the parking and try to calculate what was happening there, this is your district here, EGC, and it's going to be regulated either by the square footage of the interior area, or the whole building, I mean, to the outside of the walls, which is around 2660, or it's going to be regulated by that occupancy loading, which I think is going to be 40 persons. So these are the various things and the parking requirements, and I can't quite understand this residential work, whether this is true, that only 2 parking places, even if you had 3 units in there, only 2 parking places were required. So I don't know whether that's true. But some of the possible additional uses, you had talked about a gathering place at one point, and so at that rate it's 40 people divided by one parking place for 5 persons, which means you would need 8 parking places. And you actually can't get 8 parking places on your lot right now the way it is. And it's a push actually to get 7, but I'll cover that quickly here in a minute. And all of these various uses are requiring essentially 8 for a minimum, except apparently residential use. So that might be something to clarify with the inspector when you get a chance to talk to him. So I took those though, and I began to see if I could make this parking lot, see what kind of parking lot you could end up with. And this is the overlay, and if that's 10 foot, if we assume that they're going to allow us to have 10-foot setback to the beginning of our parking lot, this is really about the best I can do with that using typical parking lot standards, design standards. And then we would be hoping to classify this as a level of service C, which is a little more lenient, where our parking spaces are 8.5 feet wide and 18 foot 4 inches long. They would like to see 24 feet here for backing out purposes. And when you put these additional 2 parallel parking places back here, those are actually over your property line. And I mean, it could probably be done in spite of the fact, because the church isn't using that property's not using that bit there. So whether you could push those 2 places over there. The short story is, I don't see any more than 7 parking places being accommodated on that lot. That much said, you can also still make arrangements with those adjacent lot owners to rent enough land for another parking place or 2 or 3 or 4 or whatever you might like to do. So just so that you know that that is also true. If this thing here has to go to 15, then we're going to lose one of these and one of these. I mean, you could still have a little one, and one of these parking places may actually have to be handicapped accessible, depending on this, that, or the other. But I think that's it for the review. That should be enough information for you to at least be informed. That's all. Thanks very much.